Welcome back. This is part 2 of our vibe coding course. And if part 1 was about speaking like a builder, part 2 is about speaking like one, shipping, right? This is very important. Now in part 1, you mastered the vocabulary of code and version control, such as repos, commits, branches, pull requests. You learned to read, write, and talk about code with confidence. Now the game changes. We are moving from your laptop to the live internet. We are covering deployment and AI collaboration, the vocabulary that takes your project from it works on my machine to anyone in the world can use it. And here's the exciting part. We are also diving deep into how to work with AI agents and tools, the prompts, the context, the workflows, because in the AI era, briefing an agent clearly is just as important as writing code yourself. So we're going to have 17 more terms, one focused session, and by the end, you won't just build, you'll be able to ship. You'll brief AI agents with precision, you'll deploy with confidence. This is the white coder's vocabulary from code to live product, brought to you by AI-Praxis. Let's go live. Quick recap. In part 1, you learned to read and write like a builder, repos, code bases, Git, GitHub commits, branches, merges. You now speak that language. That foundation is solid. But here's the thing. Code sitting on your laptop isn't a product, it's a draft, a sketch. To become a real builder, you need to ship it live, and you need to brief the AI agents and tools that help you do it. That's where this session comes in. The vocabulary shifts now. We're talking about building and packaging your app so it's ready to run, deploying and hosting it so the world can see it, front end, back end, APIs, databases, how the pieces connect, prompts, AI agents, context windows, tokens, how to work with AI as a true collaborator. As I mentioned, 17 more items, each one gets you closer to being someone who doesn't just wipe code but builds, deploys, and ships with clarity. So let's make every minute count. Alright, so first term of part 2, and this is where shipping actually starts. It's called the build or the build process. When you write code, you're writing it in a way humans understand, readable, structured, and comments and spacing. But your computer doesn't need all that. It needs the code compiled, bundled, and optimized into a tight, efficient package that runs fast and clean. The process uh, does exactly that, which is the build here. It takes your raw code, all those files you wrote, and transforms them into a ready to run version of your app. Think of it like baking. Your code is the raw ingredients, flour, eggs, sugar. The build process is the oven that turns it into a cake. Most modern frameworks like React, Next.js, Vue run this automatically before launch. You don't even see it happening. But when something goes wrong, that's the question. You will hear this: the build failed. This means an error occurred building during packaging. Maybe a missing file, a syntax mistake, a broken dependency. The app can't run until you fix it and rebuild. When someone says run the build, they mean package my code so it's ready to deploy. Before your app goes live to the world, it needs a place to rehearse. That place is called localhost. So localhost is your own computer acting as a private temporary web server. It's a preview of your app that only you can see, no one else. Not your friend across the street, not your teammate in another city, just you on your machine. You access it through an address like localhost:3000. or something like localhost colon 5173. That number after the colon is the port. Think of it as a specific door on your computer where your app is running. Now, why does this matter? Because you never deploy broken code. You build it, you run it on localhost, you click around, you test everything, you fix bugs. Only when it works perfectly on your machine do you send it live. Now, when someone says it works on localhost, they mean the app runs correctly on my computer in private before anyone else can see it. It's the green light to deploy. Think of localhost as your dressing room before stepping onto the stage. You check your outfit, practice your lines, make sure everything's perfect, then and only then you go live. Every app lives in two different worlds. You need to know which world you are in at all times. Dev, in short for development, is the private, messy, in progress version of your app. This is where you are actively building, breaking things, testing wild ideas, writing experimental code. It's your workshop. Sawdust everywhere, tools scattered around. Only you and your team see this. Production or prod is the live, public, polished version that real users actually interact with. This is the showroom. Everything clean, everything tested, everything working, because if it breaks here, real people are affected. Here's the golden rule: you never experiment on production. You build in dev, test in dev, break things in dev, fix them in dev. Only when it's bulletproof do you push to prod. So when someone says push to prod, they mean release the version live for real users to see. It's a big moment. It means you're confident. Think of dev as your kitchen while cooking, messy, creative, experimental. Production is the dining table where guests are served. Perfect, presentable, no excuses. Alright, now this is the term that makes everything real. This is called deployment. Deployment is the process of taking your finished tested code and making it live on the internet. So anyone, anywhere with the right click, link can access and use your app. Think of it like publishing a book. You've written the manuscript, edited it, proofread it, designed the cover. Deployment is hitting publish. Now it's in bookstores, on Amazon, in readers' hands. Before deployment, your code is just files on your computer. After deployment, it is a live product running on a server, serving users, collecting data, doing what you built it to do. When someone says deploy the app, they mean take this code from my machine and publish it onto the live web. Make it accessible, make it real. Deployment is the bridge between I built something and the world can use it. Every builder lives for this moment. It's when your idea stops being private and starts being public. So you have deployed your app, it's live. But where does it actually live? Who keeps it running when you close your laptop and go to sleep? That's called hosting. Hosting means storing your website or app files on a server that's always connected to the internet 24 by 7 by 365. So anyone from anywhere at any time can access it. Think of it like this: your code is a band, deployment is releasing the album, hosting is the record store that keeps it on the shelf permanently so fans can walk in and buy it anytime. Without hosting, your app is like a pop-up shop, open when you're around, gone when you leave. With hosting, it's a permanent storefront, always open, always serving. When someone says, where is it hosted? They're asking which service is keeping your app online around the clock. Is it Vercel? Is it Netlify, AWS, a custom server? Hosting is your app's home on the internet. Choose wisely because uptime matters. If the host goes down, your app goes down and users notice. Now, when it comes to hosting modern web apps, there's one platform that vibe coders talk about constantly, and that's called Vercel. Vercel is a hosting platform built specifically for modern web apps like React, Next.js, Vue, Svelte, and more. It was created by the same team that built Next.js, so it deeply understands your code, not just stores it, understands it. Here's the magic workflow. You cannot uh, you connect actually your GitHub repo to Vercel. Every time you push code, whether to main or a branch, Vercel automatically builds and deploys your site. No manual uploading, no FTP, no cPanel, just push and it's live. And the preview feature, every pull request gets its own live preview URL. Your team can see changes before merging. Your client can approve designs before they go to production. It's collaboration made effortless. When someone says deploy on Vercel, they mean Vercel is the service hosting, buildings, serving my live app with automatic deployments, global CDN, and preview URLs. Now you might wonder, what about GoDaddy or Hostinger? Those are traditional hosts, great for simple WordPress sites or blogs, but they don't understand modern frameworks. They store files, Vercel understands code. For a vibe coder building React or Next.js apps, Vercel is the obvious choice. Alright, your app is deployed, it's hosted, it's live. But how do people actually find it? They don't type a string of numbers. They type something like AI-Praxis.co.in or google.com. That's your domain. And the system that connects that name to your actual server. That is DNS. So a domain is your website's readable address. It's what people type, remember, share, and bookmark. Instead of 192.168.1.45, which is what computers actually use, you get yourbrand.com, something like that. So there is a name, human friendly, memorable, professional. DNS, which is the domain name system, is like the phone book of the internet. When someone types your domain, DNS looks up the actual server address and routes them there, instantly, invisibly, billions of times a day. So here is how it works in practice. You buy a domain from a registrar like GoDaddy or Namecheap or Google Domains. You go to your hosting platform, let's say Vercel, and tell it, this is my domain. You update your DNS records to point that domain to Vercel server. Now, when someone types yourdomain.com, they land on your live app. When someone says, where's your domain registered, or check the DNS settings, they're talking about this connection between your readable name and your actual server. A domain gives your project identity. Without it, you're just a number. With it, you're a brand. Now we move into architecture, how the pieces of your app fit together. And the most fundamental split in all of software is this front end and back end. The front end is everything a user sees and clicks inside their browser. The buttons, the colors, the animations, the layout, the text, the images. It's the stage, what the audience experiences. If it looks pretty, feels smooth, responds instantly, that's front magic. Built with HTML, CSS, JavaScript, React, Vue. The backend is everything behind the scenes, the logic, the databases, the authentication, the payments, the AI processing. It's the engine room, invisible to users, but without it, nothing works. When you click login, the front end shows you a form. The backend checks your password against the database, generates a token, and says yes, you're in. Here's the perfect test. A beautiful button is front end. What happens the moment you click it? That's back end. When someone says, I'm a front end developer, they specialize in user experiences and interfaces. I am backend means uh, they build servers, APIs, and data logic. I am full stack, they do both. Every app needs both. The front end without backend is a beautiful car with no engine. Backend without front end is an engine with nowhere to sit. Together, that's a product. So we just talked about front end and back end, the stage and the engine room. But how do they actually talk to each other? How does the button on your screen tell the server to fetch data and send an email or process a payment? The answer is API, Application Programming Interface. An API is a defined, structured way for two pieces of software to request and exchange information. Think of it as a waiter in a restaurant. You, the front end, sit at the table and order food. You don't go into the kitchen yourself. The waiter, the API, takes your order, delivers it to the kitchen, the backend, and brings back your meal. Clean, organized, no chaos. In practice, it works like this. Front end says get slash user slash profile API, right? Please get me this user's data. Backend receives that request, fetches the data from the database and sends it back. Front end receives the data and displays it on the screen. When someone says call the API, they mean send a request to another system and get data back. It's the most common action in modern app development. And here's the AI angle. AI agents also use APIs. They call OpenAI's API to generate text. They call Stripe's API to process payments. APIs are the universal language of software. Front end, back end, AI, everything connects through them. Every app needs to remember things: user accounts, blog posts, orders, messages. But when you close your laptop, when the server restarts, when a user comes back tomorrow, that data can't just disappear. It needs a permanent home. That's the database. A database is where your app's information is permanently stored and organized so it can be retrieved, updated, and searched at any time. Think of it as the filing cabinet of your app: structured, labeled, always accessible. Here's the key distinction: variables in your code are temporary, they vanish when the program stops. A database is permanent, it lives on a server, survives, restarts, and keeps data safe for years. Real world database examples: MySQL or MySQL, one of the most popular open source databases. WordPress runs on it. Your blog posts, comments, user data, all in MySQL. Then PostgreSQL, loved by developers for being powerful and reliable. Many modern apps use it. MongoDB, a NoSQL database that stores data more flexibly, great for unstructured data like chat messages. Oracle, the enterprise giant. Banks, airlines, massive corporations trust Oracle for mission critical data. It's expensive, powerful, and been always forever. Firebase, Google's cloud database, super popular with vibe coders because it's easy to set up and syncs in real time. So when someone says save it to the database, they mean store that information permanently, not just temporarily in memory. Make it durable, make it retrievable. Without a database, your app has amnesia. With one, it remembers everything. Alright, now imagine you're building a house. You could pour the concrete foundation yourself, cut every beam, forge every nail, or you could buy a pre-built frame with walls, plumbing, wiring already in place. You just customize it, add your touches, and move in faster. That's exactly what a framework is in coding. A framework is a pre-built structure and set of tools that gives you a massive head start. Instead of writing every basic piece from zero, you start with a solid foundation and build on top of it. Real examples are like React, which is a JavaScript library for building user interfaces created by Facebook. You describe what your UI should look like, and React handles updating the actual screen efficiently. Next.js, built on top of React but adds server-side rendering, file-based routing, and easy deployment. Vercel created it. It's what many vibe coders reach for first. Django, a Python framework that handles user authentication, database connections, and admin panels out of the box. Instagram was built on it. Flutter, Google's framework for building mobile apps that work on both iOS and Android from one code base. When someone says build with Next.js, they mean that framework provided the foundation, routing, rendering, optimization, and the developer built the unique features on top. Frameworks save you months, they handle the boring, repetitive stuff so you can focus on what makes your app special. So, we have talked about frameworks, databases, hosting. Now, how do you describe everything your app is built with? That's your tech stack or just stack. Your tech stack is the complete combination of languages, frameworks, and tools used to build your app. It's your project's full ingredient list. Every layer, every choice, every technology. Real example, a typical model, web app stack. Front end, which will use React plus Tailwind CSS. Backend, such as Node.js plus Express. Database, let's say PostgreSQL. Hosting, Vercel for front end, AWS for backend. AI, OpenAI API for chat features. Version control, Git plus GitHub. Put it together and someone might say our stack is React, Node, Postgres, then Vercel and OpenAI. One sentence. Everyone instantly knows what they're working with. Another example, a simple blog might have a LAMP stack, LAMP. L stands for Linux, A Apache, M MySQL, and P PHP. A mobile app might use Flutter plus Firebase. An AI tool might be like Next.js plus Vercel plus OpenAI API. So when someone asks what's your stack, they're asking which technologies power your product end to end. It's a quick way to understand scope, complexity, and enterprise. Your stock is your fingerprint. Two apps can do the same thing with completely different stacks. Choosing wisely is a part of the art of building. Now let's be honest, your code will break, that's for sure. Okay, so typos, missing, commas, wrong logic, unexpected inputs. It's not a bug in your ability, it's just part of building. And the skill of finding and fixing those errors is actually called debugging. So debugging is finding and fixing errors in your code. It's detective work. Something's wrong, you don't know what, and you have to hunt it down. Your primary weapon in this hunt is the console. The console is a panel, usually in your browser's developer tools or your terminal, where your app prints messages and errors to help you understand what went wrong. Let's take a real example. You click a button and nothing happens. You open the console and see something like type error colon, which says cannot read property. Okay, and within quotes it says name of undefined. Now that's your clue. The code tried to access something that doesn't exist. Now you know where to look. Let's take another example. Your AI agent writes code, you run it, and the console says module not found. Axios. Okay. The translation for this is you forgot to install a dependency. One command fixes it. When someone says check the console, they actually mean look at the error log, read the message, and let it guide you to the problem. The console doesn't lie. It tells you exactly what broke and usually where. So debugging is not failure, it's refinement. Every error message is a step closer to working code. Learn to love the console. Now we enter the most exciting section of the entire course, which is working with AI, and it all starts with one word, prompt. A prompt is simply the instruction you give an AI tool. It's what you type into ChatGPT, Claude, Cursor, or any AI coding agent. But here's the thing, not all prompts are equal. Prompt engineering is the skill of writing clear, specific, well-structured instructions to get the best possible result from AI. It's the difference between a vague request and a precise brief. A bad prompt might look like build me a website. Okay, the AI has no idea what you want. You will get something generic, probably wrong. In fact, a smart AI is obviously are going to ask additional questions. What would you like me to make? A good prompt, on the other hand, says build a responsive landing page for a fitness app using React and Tailwind CSS. Include a hero section with a sign up form, 3 feature cards, and a footer. Use a dark theme with emerald green accents. Make it a mobile first. Now the AI knows what exactly you know what to be built. Real example is you want AI to fix a bug. Instead of it's broken, you say the login form at components login form.jsx throws type error. It is like cannot read property email of undefined when submitting. Now the email state is initialized as null on line 14. Fix it. When someone says prompt engineering, they mean the craft of writing instructions that get accurate, useful, high quality AI output. It's a skill, it improves with practice. It's the vibe a coding era. Prompt engineering is your super power. So we have been talking about AI tools that answer questions and write code. But there's a whole other level called AI agents. An AI agent doesn't just answer questions, it takes actions on its own. It writes code, runs commands, fixes bugs, deploy apps, all toward a goal you set. It's not a chatbot you keep poking. It's a collaborator you delegate to. For example, Cursor's AI agent. You say add user authentication to this app. The agent doesn't just give you code snippets, it reads your code base, understands the structure, writes the auth logic, installs the requested packages, updates the database schema, and even runs tests to verify it works. Multi-step, autonomous, goal driven. There's another example, Devin or GitHub Copilot Workspace. You describe a feature, the agent plans the implementation, creates a branch, writes the code, opens a pull request, and asks you to review. You went from idea to PR. You remember we discussed PR, which is pull request, without touching a keyboard. So the difference is chat AI is actually you ask and it answers, you do the work. AI agent on the other hand is you set the goal, it does the work, you review the result. When someone says let the agent handle it, they mean delegate a multi-step task to AI and let it execute, not just advise. This is where vibe coding becomes the vibe building. You steer, the agent builds. Alright, so here's a term that explains why sometimes AI seems to forget things, mid conversation. Context window. The context window is the amount of text and information an AI model can see and remember at once during a single conversation or task. Think of it as the AI's working memory, how much it can hold in its mind, simultaneously. So real example is you're working with a large code base, thousands of files, hundreds of thousands of lines. You paste a huge chunk into the AI and ask it to refactor. If that chunk exceeds the model's context window, the AI literally cannot see the full picture. It might fix one file but break another because it forgot about it. Different models, different windows. For example, GPT-4 has around 128,000 tokens of the context. Claude 3.5 Sonnet is up to 200,000 tokens. Gemini 1.5 Pro is up to 2 million tokens. So what does this mean in practice? A large context window lets the AI keep track of a bigger code base or a longer conversation. You can paste more files, reference earlier parts of the chat, and the AI still remembers. When someone says the context window is too small, they mean AI cannot hold all the relevant code in memory at once, so we need to break the task into smaller chunks or use a model with more capacity. Smart vibe coders learn to work within the window, feeding relevant files, summarizing context, using tools that auto-chunk large code bases. Now, for this section, we have the last term, and it's 2-in-1, token and model, or you can call it as LLM. That also we'll study. So let's start with token first. A token is a small chunk of text that AI model processes. It's not a word, not a character, it's somewhere in between. Roughly one token equals 3/4 of a word in English. So hello is one token, artificial intelligence is 2 or 3. Now why does this matter? Because you pay for tokens, AI APIs charge by input tokens, what you send, and output tokens, what the AI sends back, right? Longer prompts cost more, longer responses cost more. That massive code base you pasted, right? Hundreds of tokens. That detailed explanation of the AI gave you hundreds more again. So real example is OpenAI's GPT-4 might charge you $0.03 per thousand input tokens and $0.06 per thousand output tokens. A typical coding conversation might cost a few cents. A massive project analysis might cost dollars. It adds up. Okay. Now let's understand what's a model or LLM, large language model. This is the trained AI system that turns those tokens into responses. It's the brain. Different models have different strengths. For example, GPT-4 is great at reasoning, coding, complex tasks. Claude is excellent at long context, nuanced understanding. Codex is OpenAI's model specifically fine-tuned for code. When someone says which model should I use or how many tokens did that use, they're asking which brain fits this task and what's the cost. Tokens are the currency, the model is the brain. Master both and you master AI collaboration. Fantastic. So what we have looked at is 34 terms. Now we are becoming confident builder, right? You are now able to speak the language of repos and commits, of deployment and hosting, of prompts. I wish you all the best. We'll definitely meet in part 3. Till then, keep learning.